Welcome everybody. Today's discussion we're going to be discussing about the Gait Diagnosis AI, one of our own that we implemented. So the target audience and the major focus of this AI system, our primary customers were orthopedic professionals, neurology departments, and rehabilitation centers, uh, majorly uh, in low resource regions of the parts of the world, most especially our country, Uganda. What happens? The system really bridges the gap between the named professions seeking to complement their traditional diagnostics methods and therefore expand their telemedicine capabilities to even remote patients in remote settings. Well, for recognition and remembrance, our group number is SWAI 18, and I am Otai Joseph taking you through in this discussion. Understand is like also to discuss why it matters. From the problem view part of it, the major objective here is to leverage artificial intelligence to achieve gate-based skill to screening. The core problem is the delayed diagnosis of skeletal diseases just because of remote resource limitations. This is majorly experienced by our elderly individuals, manual workers, and children. Well, why would one think about solving this problem with AI? Musculoskeletal problems have subtle spatial-temporal patterns that are too dynamic that a human sight may not be able to recognize these deep down patterns. So using a machine learning model to understand them will improve the way we recognize diseases. Measurable impact will be early detection and expert level diagnosis of these various diseases at a very simple and affordable cost. The key actors and stakeholders that will be interacting with our system do include primarily orthopedic professionals, the, the fitness coaches, the pediatricians, and more important, also secondary stakeholders will include collaboration agencies like Minister of Health, Minister of Gender, and Neuro departments of Uganda. Beyond this, we should also have to partner with other government entities like National Information and Technology Authority of Uganda for some standardization, and then the online ecosystem where roles do span based on what we benefit from one another from the open source data sets, the public orthopedic literatures, and many more platforms. While using video data sets as our major source of data, the data types within these videos included the MP4 and MOV, through which the temporal spatial pattern movement was observed while breaking different videos into frames and processing this data into images while feeding our models to learn. And this was obtained from medley of medical datasets thanks to them, with clinically captured gait recordings with expert curated information about it. The processing pipeline included a collection from these named sources, filming, annotating, and validating. Beyond that, it was storage and use, model training. Ethical and legal frameworks included following ethics from medical board approvals and getting informed consent, identity normalization for personality and confidentiality reasons, and no non-commercial search use, and no re-identification permitted. The value mechanism would to promote accessible health care and early disorder detection support across the Gait Analysis Research Centers and the medical computer vision benchmarking as part of our research. To summarize the whole system, the system is majorly an artificial intelligence method. We are solving this problem, and we are using large vision model with a 3D CNN as our student model, while following a teacher-student distillation framework with bioclinical BATs based for our clinical embeddings, where the model takes in our gait videos, breaks it into frames per second, and then learns patterns in deep insight. That is our teacher model. That knowledge is passed in a form of probabilistic distributions to guide our student model while learning, whereas the clinical BAT converts the clinical literature into vector representation, which also tells our student to what to learn in which video. This makes us come up with an informed form of student model ready for deployment that was deployed in Hugging Face, and then therefore system integration had to take in place. The front end and mobile apps were therefore needing to communicate with the backend deployed on Hugging Face. While doing all this, we maintain that we maintain principles and standards, encouraging privacy, preserving by preserving anonymization, uncertainty flagging for human reviews, and then favor false negatives rather than false positives in case of uncertainty. We don't want to under-diagnose. It's better to over-diagnose. No one should be left sick, uh, left to be okay, yet in actual sense he is sick. That's why we favor false negatives rather than false positives. Key matrices and evaluation within our system, it delivers 81% recall, 89% precision across the 9 different classes that it was trained on. This therefore makes it better for clinical use. We compacted and optimized this to a level of as small as 3.5 MBs, ready for mobile use in real-world clinical scenarios. The adoption and trust with clinical uptake in 3 months, we think in every 5 clinical satisfactions, we take almost all with a 4.6 out of 5 and strong engagement demonstrating reliability and confidence among health care professionals. With this all, the ethical and fair part of it, we also use confidence scores to flag uncertain cases for expert reviews, prompting safe decision making while maintaining patient privacy. Well, as it gives a prediction, it gives a confidence score. To what level is it certain that one is a victim of this? This can be a benchmark for assessing the degree of sovereignty. Some percentages for reasons can be taken to be normal, and beyond some threshold, one can be declared a victim. Impact and scalability proven by the cost effectiveness and the scalable design embodying the microservice architecture makes it extensional and be able to add the additional different classes, broadening of the medical screening application. So the advantages and the differentiation between our system and other existing systems. One is that The privacy laws, usually we agree during sign-up, gives us intellectual property and gives no one right to duplicate our system. And so, if they go ahead, they may achieve the functionality as we have, because during our model training due to imbalance, we also achieved our custom laws functions because of the sampling techniques for rare disorder detection while using imbalanced datasets. Continuous versioning and weekly updates to the orthopedic literature from 15 plus clinical corrections to stay ahead of the curve and constantly improve the model gives us a step ahead from other implemented. Our system can be accessed as developed. It was optimized for search engines, so as you type across the web, you can likely get it. Also, webinars, social media campaigns, API documentation portals, and community outreach programs, radio broadcasting, hospital referral programs, and many more. You can be able to hear about our product. Delivery channels do include mobile applications, web applications, application programming interfaces, platform integrations, and many more. Partnerships do include collaboration with universities, non-government organizations, referral hospitals, and others. And the revenue streams that we can have, we do have one of, first of all, software as a service. This can be achieved through subscriptions while licensing it to other third-party organizations, some to sponsorships. This can be our direct revenue stream. Indirect revenue streams can be data as a service through consultation services for system design and implementation within our ecosystem, as discussed in the previous session. The freemium and trade access, as you sign up and use the features, also generate some income for the system's upkeep. The value added streams through sponsored research, the analytic dashboard, and white labeled AI tools all generate some income for this. Number of key resources are mandatory from human resource, the technical infrastructure for hosting, and everything as far as cloud and is concerned. The data infrastructure from where we get our custom data sets, the open source data sets, and all that do need important resources in this. And then organizational resources like the university itself, the partnered organizations, the National Referral Hospital, Mirago. Financial resources do include the national research grants, especially within and outside the country. The key activities within the system do include the model life cycle itself, from where we collect real-world gait clinical videos and orthopedic literature to the point where we develop the real system to operational activities that include making sure that it's available to users through all mobile and web applications. This can also be through application programming interfaces that we establish for communicating with external softwares. While doing this, we govern and comply with some principles to regulate fairness and check through independent AI audits to ensure full compliance to medical and protection data laws to maintain transparency and trust. Customer-focused activities like customer support and introduction into new features in the system will be part of the key as active. The key partners do include the hosting companies, for example, Hidden Face, Verso, many more. Data partners do include all health organizations, more importantly, Makerere University College of Health Sciences, and the health institutes around. Ethical oversight partners do include the Ministry of Science, Technology and Innovation, to ensure that we comply to the established standards and principles. Distribution partners do include marketing companies and, for example, MTN, Airtel, to make our application available to intended users. Strategic collaborators and affiliates can be Unipod, Innovation Fund, Google Startups Africa, House Tech Africa, and many more. These are key partners we look forward to working with. While estimating the costs, we allocated based on the experience achieved throughout the process. Human resources are almost needed, almost half of everything. We accredited it to contribute to 50%, followed by data costs, following the hard part of achieving custom data sets, the infrastructure on which the system will be running, the maintenance and scalability part of it, marketing and distribution, and then also compliance to legal laws. This will cost a fraction of what. For scalability and sustainability, we implemented the microservice architecture where failure in one of our components can't bring the whole system down. This gives our system a step as far as sustainability is concerned. The continuous learning and governance through our automated ML pipelines with feedback loops. These detect any drifts, and then with model metrics tracking ensures that models stay accurate and clinically validated. Uh, The localization and accessibility, as talked earlier on, we've made it available offline to a final user. And then reliance and continuous improvements through our model backups, the dataset backup itself on cloud storage such that we can't lose any part of our. While intellectual property and innovation within this gait analysis system, we see the core innovation of the idea encrypted within the four major principles, where we keep our trademark, we keep our customers' secrets for privacy reasons, following our rules and copyright, and then our patent. In conjunction, we achieve a core innovation of gait analysis as a platform. With all that said, the team contributions from I personally, Ty Joseph, a cloud engineer, a Brake Emmanuel, a machine learning engineer, Agaba Durek, a systematic. Thanks to them all. With all that said, I open the floor for any questions. Thank you for listening.